We'll get into that later. But we've got export capabilities. We'll first kind of say, well, let's find an example telemetry parameter. I think pretty much everybody kind of knows what those are. So the find facility is optimized for speed. You know, we use databases in practical reality that are on the order of 250,000 telemetry parameters and several hundred megabytes. This one's only a few kilobytes, so you're really not getting a speed demonstration. So if I found a parameter, I could just go grab that from the list of telemetry parameters. And some of the key capabilities that we built into this were designed to actually help our integration and test team as much as anybody else. For example, if I take this sun sensor mode parameter and just pull out the details, you can see that in this case it's one of those multi-state or enumerated parameters where you have a number that maps to some sort of a string value. Here we have this off, low, and high. Well, in the simplest possible case, we've got a little decommutation and commutation engine that's actually built into the tool, and you can use this to sort of validate what your XTCE document, what it represents and what should actually output in your ground system. So for example, I type the word low for an engineering value and press the generate button. Whichever row you happen to select, whether it's the engineering units or the uncalibrated or the raw value, it automatically generates the other two for you, so you can kind of see how they come out. We do something a little bit more complex, so you can pick this sun sensor level. This is a kind of an example of what you might get from a digital to analog converter. You get a number of counts and you convert that with some sort of a calibrator into an engineering unit. In this case, I just sort of made it up. You see you get a -10 + 5. Well, all of it works straight through the encoding and decoding engine. So if I wanted to say pick a number of counts of 5, I'm going to get a +15 as the engineering unit in that case. The tool actually also supports the much more complex math operation calibrator that's in XTCE, which allows you to really generate any arbitrary equation that you like. In this case, XTCE requires you to put it in reverse Polish notation. Some people like that, some people don't. The tool automatically interacts with it and does forward and reverse between postfix and infix, so you can see it in the standard form that people are used to seeing, especially our operators who would much rather see it the way they saw it in college. So it supports all those kind of characteristics. Another common question that, say, for instance, we get from our operations team is they'll look at a parameter like this, or they'll get a list of parameters, and they really want to know, okay, well, what telemetry packet does this occur in? So we've built in those kind of search capabilities as well. So if I take any of them and say show usage, it'll tell me what space packets, in this case, whatever containers in XTCE that parameter happens to appear in. If I say select CCSDS space packet 2, for example, sometimes these come out of it. You see something sort of unusual here. There's a gap defined in a little pictorial graphic, and some orange that's on the list. So what the library underneath is capable of doing is taking very complex inclusions and restrictions and those container definitions in XTCE and decomposing it into basically a table, which is what most end users really like to have, right? XTCE is kind of hard to put together, so they like to see this table. I really just want one row per item, and that's the easiest for me to parse, right? So the library provides that capability for the end user, and also for this user interface screen. In this case, we've got some cases where you have conditional include, right? So in this particular instance, we've got a solar array voltage, which is only really included in the packet if the solar array mode is actually on, right? When it's turned off, maybe it doesn't mean anything. And there's a lot of cases you see that in the database. So for the sake of the UI, you can right-click on it and establish that conditional, and it will automatically reevaluate your packet as if those conditions happen to be true. I've also done some documentation with this tool with assistance, because you can take this drawing that it generates and go ahead and save that off as any kind of a graphic file that you like. Supports a whole bunch of different formats. Well, you can go ahead and stick that in a PowerPoint slide, or you can stick it into an ICD document. For example, if you were to happen to pull the header out, you might want to document just the CCSDS header and stick this little image into a document. And some people like to see their drawings top to bottom as opposed to left to right, so we kind of built in both capabilities where it can draw it in both orientations. The top to bottom is kind of nice for very long packets because then they fit a little bit better. You don't have that trouble with the parameters getting a little bit too tall. So even though the streams are rather helpful, usually if I'm giving this to an engineer, I'm actually directing them to go take a look at the stream dialog as opposed to the container dialog. Sometimes that's a little bit more intuitive for them. So when we import these into a product like an OS Comet or an L3N Control or a Kratos product, it's generally going to be organized by the stream. So for instance here, this attempts to decompose the whole stream for you and allow the end user to pick whichever item from the stream they like. So if I, for example, take this packet utilization service 1 subservice 2, go back to that, we can go a little bit further with that built-in telemetry, that built-in commutation and decommutation engine, and we can actually do it at an entire packet level. This was helpful for our INT team because they were able to look at output from the satellite, decide they were kind of dissatisfied with what they saw, go to the raw packet log and pull out a hexadecimal string of what that packet contained, right? Well, they can go ahead and put that hexadecimal string, if I hit decode here, and just paste it in, and it will, so to speak, decom that packet, sort of like an OS Comet would, and then they can kind of go down and browse the values and say, hey, am I getting the same answer from my ground system as I am from this little tool? And if I am getting the same answer, the chances are we're probably both right. If we get a different answer, then maybe we have to head scratch a little bit and figure out who should be making it. And it works actually in both directions. So when we designed unit tests, we actually went the other way. We did this encode methodology. And the encode methodology is kind of nice because it allows you to kind of put in arbitrary values. So you can pick challenging values. You can pick ones that you want to test boundary conditions with. And as you fill in the values for here, if I just, for example, put one in, it automatically fills in the other two areas, and it builds your packet hexadecimal on the fly. So you can then just copy that, stick it into a packet injector into your ground system, as if it was a standalone packet, and watch everything flow through, see your telemetry page on the screen, and hopefully, again, they agree. And again, you can, of course, then encode that into unit tests where you send a whole bunch of these, right, and look at the expected responses. Maybe the same thing works, of course. We, on the Iridium program, managed to capture not just the telemetry and the telecommands that one would typically be familiar with, but we also capture all of the onboard configuration tables. And I've been encouraging all programs that I've been working with ever since that point to really do the same thing, and not to develop a separate set of tools for a payload configuration or calibration table. Incorporate it all right in the database, and you can use the same library toolkit for encoding and decoding these things, going up and down for everything, not have a separate tool for every single step of the way. So again, in this one they've actually made some usage out of because they can just come up here and change whatever value they like, and it's going to automatically update that hex and they'll know what they have to upload. So it saves them some development time in the end to be able to do that. So thinking on the world of telecommands, it actually all works the same way. If I pick this sort of reaction wheel command here, I end up with the ability to do all that same encoding and decoding that I could do before. And again, it fills out all the fields that either have defaults or have mandatory values based upon the restrictions of lining up a packet in XTCE. It's got it all figured out for you. So going out of this tool, I mean, if somebody's not writing their own tool and using the library per se, maybe they have their own system that they want to be able to kind of import data into, we have the capability of importing and exporting telemetry packets, telemetry parameters, telecommand definitions, and you could say, jump it right to a CSV file, bring it up in Microsoft Excel if you want. Okay? So you don't have to stay within this particular domain. To help developers, and this is actually, the community has sort of started to use this. We've got several contributors now. The application programming interface for the library is completely documented in JavaDoc. This particular application happens to be implemented in Java. So you can go running through the toolkit and get all the class examples, and you can even get examples of how to start if you've never done anything before. So these are a whole bunch of example main functions that use this library to do some particular features that you can see that this GUI does. For example, decoding a container, which is one of the things that this GUI is doing, and showing you a table of all the parameters in the container, all decomposed based upon the contents of the container. Well, you've got a programmatic example of how to do that right out of the gate, and all you have to do is add your own sugar to it in terms of what it is that you plan to be building. In addition to that, if you don't have an easy access to really get documentation on the XTCE schema in a visual way, we've gone ahead and included documentation directly on the XTCE schema within the tool itself. So if I arbitrarily pick any one of those XML elements, that you'll get the actual verbal description. And I realize that on the projector screen, this is going to be kind of small for people, but the point's there, right? And it has Drive. You can click through and get to any particular piece and discover what all the facets of the schema relationships are, and what the restrictions are, and whether you have to put something or whether it's optional. And because we were, at the time, working with the Europeans, I decided that this had to at least get a full set of internationalization. So it's kind of one of the very few tools in the space industry that I'm aware of that is capable of doing that. I have at least one additional language built into the tool, which happens to be French. And unfortunately, you actually have to restart the tool in order to get a language change to take effect. Hopefully, people don't make language changes too terribly often. But now if I bring it up, I'm going to get everything in the tool itself being, well, in French. It won't convert your actual XTCE database file, so that'll obviously still be in English. I can't do that. I've had one other request now for German, but I'm not qualified to actually make the mapping file, but the mapping files are relatively easy to make. So anybody who wants to sort of map it into another language can do that in an afternoon, and we'd be happy to take it into the project. Go ahead and submit it. So this is all absolutely free, open source. This is not a product that anybody sells. We donated this to the community, or actually I did. You can get this online from gitlab.com. The link is available, I think, at xtce.org. And if you're kind of curious about the code itself, the entire package is run through a product called Coverity Scan, which is a really, really good code quality and code security validator. And we get a pretty high score with them. In addition to that, we have code coverage analysis at the unit test level for the entire library that runs between 70 and 85%, depending on what package within the library that you're using. Now, we don't count it on the UI, because the UI, unfortunately, has to be tested manually. But the important part is the library. And if you happen to be writing your own application, and you're using Java and Maven, all you have to do is declare XTC tools as a dependency. So right here at the Sonatype public Nexus repository, Maven Central, if you just put this XML block down there in your POM XML file, it'll automatically pull XTC tools, and you can go ahead and use all those API functions in any application that you happen to be writing. So, or of course, you could clone the whole thing and make modifications and tweak it to your needs. So Louise is standing here telling you we're probably close on time. And this demo actually can run upwards of an hour. It has in the past. So there's a lot more to the tool that I didn't show. I tried to touch on a lot of the highlights of the main things that it can do. I didn't touch on aliases, which I should have. That most organizations have multiple names for parameters, and the tool handles that in a very elegant way where you pick namespaces for whatever your aliases are. And you can have it show all of your parameter names and command names in their flight software variable names, or you can have it show it in these numeric values, which are legacy on many programs now, right? They'll have an ID number, or you can have it show it in an operator name, and you can tell it right at the top of the tool to flip between those. And it automatically updates everything and allows you to operate in any of those domains. So that's happy to give it back to you.
Dave's tool is excellent. If you've ever read the XTCE spec or seen an XML database in its raw form, it is overwhelming, to say the least. Having access to this tool on his own time, I mean, he pretty much is blood, sweat, and tears on his own time. He doesn't get paid for it. Is very appreciative, and I encourage you to go download it, play with it. It's super duper impressive. So I'd like to collect the cards, and while we do that, I want to make sure that we point out Steve McLeod in the back corner. For those of you who don't know him, he's an OMG Senior VP, and he's, I think maybe 3 years ago at Reston, or 4 years ago, we were up in a tiny little hotel room with 2 of us and 1 guy on the phone. Was the Space Domain Task Force at the time. And Steve really is responsible for growing us. He puts in the legwork. He makes tons of phone calls to get people to participate, and it's really taken off over the last 4 years or so since he's been involved. So thank you, Steve. If you'd like to chat with him, he has to leave at 2:45 or 2:50, so you may want to catch him before he has to jump out. If you have any questions. Yeah.
Or see me tonight at the system.
That's right. Get back. Okay, so I'm actually going to start off with the first question for our panel, and this is going to be directed at Afshin, since she's our fantastic end user who's decided to join us today. The question is, what interfaces involved in satellite and space mission control would you identify as having the greatest current value in standardization, either because there are no standards or the existing standards are inadequate?
So I would say that, whenever you have a situation where there are distributed stakeholders or distributed systems, that adding a standard or applying standards can have the most value in those cases. So that's a generic answer. But so standards can introduce a great deal of compatibility between systems and also save money, which is very important to all of us. I would say that we need a top-down approach for missions, and we would need to identify where do standards exist and where are the gaps, and then try to enhance the existing standards to fulfill those gaps. So for example, we have GRDDP, we have SpaceWire, we have CCSTS. So where do we have items that don't fit into those standards? So for the example for XTCE, we knew that file dumps, memory dumps, file loads, those types of mission critical functionality, that functionality didn't fit into the XTC standard. So perhaps it is possible to introduce standards for those functions, which are common to almost every mission. Further, I'd like to say that we have a new initiative at NASA called Restore-L, which is a satellite servicing mission. And that mission is going out and servicing satellites, some of which weren't even designed to be serviced. So the Restore-L people have to figure out how do we cut through blankets that were never designed to be cut. So even for the external interfaces for satellites, we could possibly have standards so that future servicing missions could have a standard approach for even cutting through blankets or for, refueling satellites.
Great. So we have end users here. We have people involved in creating the specifications who also happen to be vendors. And so I'm going to let one of you guys, either Justin, Andre, or Dave, chime in on that if you'd like.
So, yeah, I'm somewhat passionate about this particular question. As a end user of COTS and GOTS, one of the things that attracted me to XTCE was trying to produce the mission unique software and the customization that's required in every mission. And there's a hole in XTCE that was conceived of but never quite finished about stream definitions. Because I really want to have a plug-and-play way to describe not just my telemetry and telecommand database and my various calibrations and file uploads. I want to be able to characterize the stream so I don't have to write custom interfacing software for each of the ground systems. That's a cost that I think can be avoided with the right work in the standards community. And unfortunately, we're not quite there yet. But we're working on it. We delayed XTC 1.2 for a significant amount of time in order to capture many of the customizations. And I saw some that I even recognized from Afshin's presentation in order to make sure that in 1.2 we would have better fidelity, but we were not able to get to the streaming stuff.
Justin?
I'd say that recently we've seen like a lot of, I'll say, newer companies entering the market because of those small sats and CubeSats, and they're just wanting to bring and utilize like newer, I'll say, general purpose technologies like REST as an example. And what we're noticing is while those technologies are awesome and we love to use them too, it isn't a complete standard, and it's not even actually a standard, but it isn't complete. It's a technology that you can use to build applications, but it doesn't specify how you name things and how you use these APIs. And so while it can be quick to get to market, it doesn't necessarily mean it's interoperable. It doesn't make it so that you can easily, I'll say, connect other software or products without additional software development. So the use of standards is important even if we want to lever, I'll say, recent innovation like REST and other technologies, JSON, because it doesn't actually define how you use them, but that's where the standards body can definitely come in, and I think C2MS is definitely a great example of that, defining more of these messages that can then ride on different standards. So,
Andre, I'll ask you a little bit of an offshoot of that question. Afshin, mentioned kind of the vertical integration of the entire, space link, and L3 does, touches on a lot of those pieces. How eager, beyond XTCE, how eager are you guys to participate in maybe filling some of those holes with standards?
Oh, very eager. I think what we'd like to touch on, is, for example, we're discussing in our committee the displays. We create our own design, our data display package called J that works with aircraft, satellites, or other, and in order to create some sort of a data display markup language or something that allows you to just transfer display information in between ranges or in between control centers for satellites, that would be awesome. Also archiving is something that would be very good to create a standard on, and we'd be very interested in doing that as well.
What Andre touches on there is that it's very difficult for programs to switch vendors typically, because not so much that there's purposeful tie-in, it's just that the industry